Hi students, this is Mr. Yao. Today we're going to talk about 4.3, where we'll learn how to identify even and odd functions graphically and algebraically. First, let's learn what is an even function and what is an odd function. A function is defined as even if it is symmetric to the y-axis. So basically, if we have a graph, say like that, you can see the left side of the y-axis and the right side, they're the same. That means it's even. A function is defined as odd if it is symmetric to the origin. So for example, if my graph is like that, the left top part and the right bottom part, they're kind of like similar. I meant to draw them as the same. And that means it is symmetric to the origin. So if I actually just flip or turn or rotate around the origin, I'm going to get the same graph. So that is an odd function. If it's not symmetric to the y-axis or the origin, then it's defined as no symmetry, or we just say it's neither. And most of the functions we see are actually fall into this category. So let's see some examples. First one, I'm going to see the graph is the bottom left part and the top right part, they are actually symmetric to the origin. So basically, if you pick a random point and you can see, oh, it's kind of like the same distance, and extent is another point on the graph, that means it's symmetric to the origin, so it's going to be an odd function. Example 2, we can see the y-axis is right there, and there's nothing like on the left or right. The whole graph is actually on the right side, so it's not odd or even, which means it's going to be neither. Example 3, we can clearly see the left side and the right side are symmetric to the y-axis, so it's going to be even. Next, example 4. So it's a straight line, but that means the left side and the right side, they are the same, so it's even. Example 5, we don't even have anything on the left side, so it's clearly not even or odd, which means it's going to be neither. Example 6, we typically say the left side and the right side needs to be the same for even, or symmetric to the origin to be odd. In this case, if it's actually even, the graph needs to be like that. If it's actually odd, the graph needs to be like that. So clearly it's not any of them, which means neither. Example 7. We can see the right side only has this bottom part, the left side has this, and it's not symmetric to the origin or the y-axis, which means it's neither. Example 8, it is going through the origin, so that means the top left part, if we just rotate it 180 degrees, we are going to get the bottom right part, so it's going to be odd. But that's also another way to think about if it's actually symmetric to the origin. Next, we can see the left side and the right side, they are kind of mirroring each other, which means it's symmetric to the y-axis, so it's an even function. Now, if we don't have a graph to look at, we can still use algebra to find whether or not our function is even, odd, or neither. And here's how we can find it. Given f(x), we're going to try to evaluate f of negative x. So if you think in a graph, that means if we have, say, like the right side of the graph, we have x right there, we get an fx, which is this value. We're going to try to find y and negative x, so it's going to be to the opposite side, which is right there, negative x. We're going to see if it's actually going to give us the exact same value or it's the opposite value. That can tell us if it's symmetric to the y-axis or the origin. So if the value we got, f of negative x, is actually exactly the opposite of what we have. In this case, we found negative x there, and it's the opposite right there. That means the graph is going to be to the opposite side. It's symmetric to the origin, so it's going to be odd. And if the case is the value we found is the same as the f of x, that means it's going to be to the symmetric to the y-axis, so it's going to be even. If it's not equal or the direct opposite, that means it's not even or odd, so it's neither. Now let's look at some example to go through that process. Example with steps. First, we are going to replace wherever we see x as negative x. So first, we're going to have f of negative x. We see x there, we replace this with negative x, but we don't change anything else, plus 4. Second step, we're going to simplify f of negative x. In this case, it is. And the third step, we are going to compare our fx and f of negative x. Our f of x is x plus 4. Our f of negative x is negative x plus 4. Clearly, first, they're not the same, and that means it's not even. Also, if we want direct opposite of that, is going to be negative x plus 4, which actually is going to be negative x minus 4. Clearly, that's also not the same as negative x plus 4, so it's not odd, which means the answer is going to be either. Now let's see another example and go through the exact same process. We're going to find f of negative x. So wherever we see x, we replace it with negative x, so it's negative 3 times negative x, which is going to be a positive 3x. So clearly we can see f of x is not the same as f of negative x, because one is negative 3x, the other is 3x. But we can see 3x is actually the direct opposite of negative 3x. So f of negative x is actually the opposite of f of x, which means it is an odd function. Now let's see a few more examples. Example 1. Same thing, replace, so f of negative x is going to be negative x to the 5th power. And if we know to distribute the power, it's going to give us negative x to the 5th power. So clearly, f of a negative x is not the same as f of x. When we say the same, they will just appear to be exactly the same thing. But this one has a negative sign, but you can see negative x is actually the direct opposite of x to the 5th power, so it's going to be negative f of x, which means it's going to be an odd function. And for these functions, you can also graph them on your calculator to actually have a look and decide if it's symmetric to the y-axis or symmetric to the origin. That would also work. Next, you can see example 2. First step, same thing, replace all the f of x, g of x in this case, as negative x. So wherever we see x, that's negative x. And then it's negative 4 times x plus 4. Then we're going to simplify it. It's going to give us x squared plus 4x plus 4. So clearly it's not the same as the original one. So it's not even. And now if we want this to be the exact opposite, it's going to be negative x squared plus 4x minus 4. That's what is actually going to be the opposite of that, negative g of x. And clearly, g of negative x is also not the same as negative g of x. So it's going to be neither. Next, example 3. Same thing, replace the x as negative x. We got negative x squared plus 6. Since it's negative 1 squared, it's going to just be positive. We're going to get x squared plus 6, which we can see is actually the exact same as the original. So f of negative x is the same as f of x. And we're going to simplify that, and we can see they are the same, which means it's going to be an even function. Next, example 4. First, replace, so h of negative x is negative x. And absolute value means anything that was negative is going to be changed into a positive. So that happens to be the same as just an x. And that means it's the same as h of x. So it's an even function. And absolute value is kind of special. You might want to look at some graphs. So for this one, the graph looks exactly like a check mark. And that is also why it's symmetric to the y-axis, and it's even. Example 5. So we're going to replace x with negative x, get negative x plus 3. So think about it. If we actually take out that negative sign and try to make it a positive, that's going to be negative, then x minus 3. So even if we take out the negative sign, because it's absolute value, we can get x minus 3, which is not the same as x plus 3, or the opposite. This is not the same as f of x, and also not the same as negative. So that means it is neither. Now example 6. Then replace x with negative x. We're going to have 5 over 4 negative x minus 1 squared. And the best way to actually evaluate this is if we actually get rid of the parentheses. So for the top one, f of x, if we get rid of the parentheses, it's going to be 5 over 4 x squared. Then we're going to minus 5 over 2x plus 5 over 4. I'm just multiplying everything open, distribute, and that's what you should get. As for the bottom one, if you actually open it, it's going to be 5 over 4 x squared plus 5 over 2x plus 5 over 4. You can see clearly it's not the same as f of x. And if we want everything to be the opposite, the front needs to be a negative 5 over 4x squared, which is not the same. So it's not the same as negative x. So it's going to be. And if you graph example 5 on your calculator, that would give you a graph like that. And if you graph this one on your calculator, it's going to give you something like that. So you can kind of see it's not symmetric to the y-axis or symmetric to the origin. Now example 7, we have two functions. The first one, y equals 5. That means every single value on the graph needs to be, the y value needs to be 5. So it's actually going to be a flat line at 5, which means it's actually going to be even. For x equals negative 5, x equals 5, that's going to be a vertical line, so it's neither. Example 8. Let's change x into negative x, so negative x equals negative 2, the negative x inside, 4. This is a negative x with absolute value. It's the same as just an x, for which we can see it's clearly exactly the same as fx. So that means this is an even function. If you actually graph it, the graph looks like, actually it's going to be facing down, and the graph looks like that. This is f4. You can see it's symmetric to the y-axis. That is everything for even and odd function. Thank you.